Hayden, stop it.
Subscript.
No, a subscript when it's written at the bottom.
Is it the power?
It is a power, yes. Okay, and that's a word that we use sometimes with it. So we're going to put exponent up here. And I'm going to put in parentheses power. So whenever we're talking about powers, stuff being raised to a power, we are talking about the exponent. I want to make that abundantly clear. Now, whatever is being raised to the power. So whatever is at the bottom, it could be an X, it could be a number, it could be a Y, it could be whatever, okay? But the base is the number, the variable, whatever that is being raised to a power, okay? And for a lot of the rules we're looking at, in order to use them, they must have the same base to use a lot of the exponential properties. So when we're trying to combine exponents and do all the things, we can't do it without having the same base. DeVale, Aiden, sit up. Wakey, wakey. All right. Now, so we're going to go ahead and look. Shh. Steely, eyes on your own paper.
We're not even writing anything.
I don't care.
What are you looking at?
All right, so for products of powers. So if we take two things with the same base and we multiply them together, okay, our exponents, we can do what with them? We don't multiply, we need to add them together. And so over here, if I look at this problem, I can say 3 to the third power. And we get that by saying 4 plus -1, which is 3. And what is 3 to the third power?
9.
No, 3 squared is 9. What is 3 cubed? 27. Which, that is the date, which is why I have January to the 3 cubed up there, 2025. 27th is the date.
I was wondering why you had that.
Yeah. And so it's wrote as 3 cubed because I was being funny.
She messed up something.
No, it is 3 cubed because it's the 27th. And it was a good day for me to make that pun because, like, we're learning exponent rules. Great. Now, whenever we're taking a power and we're raising it to another power, what do we do with those two? Multiply. Okay? So, over here, we're going to do 4 to the, what is 2 times 3? Yep. Now, use one of those calculators and figure out what 4 to the 6th power is.
87.
7.
75.3982.
I got
Oh.
4096.
4,096.
Yay. I got a credit.
Oh, close.
All right. Now, we are going to look at this one. So, for this one, it is a power of a product. So, these two things are being multiplied together and then raised to a power. So, if this was numbers like 2 and 3, I can just multiply the two numbers together, then raise it. Okay, but when it's variables, which is what we're going to deal with a lot, I have to make sure that both variables get the exponent. So that's how we're going to practice it, is like we were doing it with variables, because I want us to be in the habit of doing that when we get to the variables. I don't want it to come out of nowhere. Okay, so here, that is like saying 2 squared times 3 squared. What is 2 squared? What is 3 squared?
9.
What is 4 times 9?
36.
36. Now, the other way we could have done that, what is 3 times 2?
6.
What is 6 squared? 36. Yeah. That works. But if it was a variable, we could not do that, which is why I wanted to go about it the way we did it. Because I want us to make sure we know what things we need to look at. Now we're going to look at negative exponents. So a negative exponent, what it causes to happen is it's going to cause it wherever we have a numerator and a denominator, right? Every number can be written as a fraction. How would I write that number as a fraction? Put it over what? Whenever we have that negative exponent, it's going to cause our fraction to flip, okay? So, like, a to the negative m is going to become 1 over a to the positive n. So, if it's in the numerator, it's got to go to the denominator. If it starts in the denominator, like here, it's going to cause it to flip and go up to the numerator, okay? And we're going to look at why that happens in depth in a couple problems, actually, okay? So that is what's happening. And here it says where a can't be 0, because what would happen if a is 0? Can we divide by 0? No. So that causes a problem in our questions. So down here, what would I do for 8 to the negative 2? What does it need to be moved to a numerator or a denominator? Denominator. So we'll do 1 over 8. Does my exponent need to stay negative or become positive? Become positive. And what is 8 squared? 64. Now this one is in the denominator. So does it need to stay in the denominator or move to the numerator? So we get 8 squared. Okay? 8 squared is what? 64. Okay, the next one is actually one of my favorite ones. Okay, so for this one, 0 exponent. Anytime we have a 0 exponent, it's going to make whatever the number is 0. The only exception to that is when the number you're raising to the power of 0 is 0. And so if I have 5,280 to the power of 0, it's going to be? Did I missay that? I'm so sorry. Anytime you have a 0 power, anything that's raised to the 0 is 1. Okay? I'm going to show you why that is in just a second. So 5,280 to a 0 power is 1. Negative 7,500 to the 0 power? 1. 5 to the 0 power? Negative 8 to the 0 power? So 5 to the 0 power is? Negative 5 to the 0 power? 1. So we are going to look at why that happens. So I've been doing it up on the board, but I am also recording my screen at the same time. So I'm going to do it right here, okay? So I want us to kind of talk about why that happens. So when we have a to the first power, that is the same thing as saying a. Do y'all agree with that? If I have a to the second power, we get a times a. Do y'all agree with that? What about a to the third power? What do we get for that? A times a times a. So each time we multiply another a to the front of that. So what is the only number I could put there that would keep that trend going? That when you multiply a times it becomes the next one?
Nothing.
Not nothing, because what would happen if we said a of 0 equals 0? And then I try to put 0 times 0. What would happen to all of those things when I do that? 0, right? And so what's really happening is that exponent is telling us how many times a is being multiplied by itself. So if a is being multiplied by itself 0 times, okay, that is what leaves us with just 1. Because if I put 1 in the front of all of these and let that trend continue, does it change my answers? No. Okay, and so that's why when we do this, a to the 0 power is 1, not 0. Because it's taking the placeholder of, oh, what would this be if there wasn't an a there? Because we have that understood coefficient in the front of 1. And so it's like taking the a out of the equation. And the only way to do that and make it so that we still keep that pattern is by doing it that way. Now, we're going to go to the quotient of powers. So when we multiply two bases together, we add their exponents. What happens when you divide them? What would be the opposite of adding? subtracting. Okay, so again, we can't have where the bottom is 0 solely because, can I divide by 0? No. So over here, we are going to set this up and we're going to do 4 to the 3 minus negative 2. What is 3 minus negative 2? 5, because what happens when you subtract a negative number? You add. So you get 4 to the 5th. Use your calculator to tell me what 4 to the 5th is. 1,024. All right. Now, we are going to go ahead and look at this last one. And now if we take a quotient, so a fraction, and we raise that fraction to a power. Basically, all that happens is both the numerator and the denominator get raised to that power. So in this problem, we have 2 to the 4th over 3 to the 4th. What is 2 to the 4th? 16. What is 3 to the 4th? And that would be our answer. Because can we simplify that any? No. All right, and we're also going to look at some of these problems. We're going to try to get through most of the ones with numbers today, and then tomorrow we're going to look at what happens with variables, okay? So for number 1, what do I need to do with those exponents? Add, subtract, multiply? Add. So we're going to do 3 to the 3 plus 2, which is what? 3 to the 5th. What is 3 to the 5th? 243. All right, for this one, what's the understood power on that first parentheses? 1. So I would get negative 5. What is 1 plus 4? Because we do 1 plus 4, so we get negative 5 to the what power? 5th. What is negative 5 to the 5th power? Exactly. Now, one of the probably the most common mistake that's going to be made this entire unit is going to be messing up with negatives in our powers, okay? So underneath this, we're going to talk a little bit about what's going on. So if we have negative 2 in parentheses squared, type that in exactly like that to your calculator and tell me what you get. Just like that. Type it in. It is 4. Okay? And we know that's true because negative 2 times negative 2 gives us 4. Now, we're going to look at negative 2 squared equals, what is that going to be? Negative 4. So the difference there is the calculator reads that second one as negative parentheses 2 squared. So that negative is just outside of it. Then it says 2 squared. Yes, ma'am. Yeah, go ahead. And so that is what gives us the negative 4. Okay, those two statements are completely different. And that's why it's super, super important to pay attention as we're typing this stuff into the calculator. Because there is no telling how many times in my teaching career kids have missed a problem because it was this, but they typed it in like this. Okay, or vice versa even. So we just have to be very, very careful with that, okay? And be very mindful when we're typing into the calculator. Most of these problems, when you have, actually all of these problems, when you need to do it this way, it says that in the problem. It shows you that. Just make sure you type it in that way, okay? Now, in addition to that, I do want us to talk about something else as well. Okay, so there is a couple rules you can use to help you make sure that what you're doing makes sense. Okay, so if you're worried that you messed up on typing it in, there's a couple ways you can kind of check yourself. Okay, so one thing that I always do is if I have a problem and it's written like this, automatically I look at it and go, oh, okay, this negative isn't included in that. So because that negative's not included, I'm just going to put it there. Okay. And then 5 squared is what? 25. When I have one of those problems, that's one of the first things I do. When I see that there's a negative not included, I go ahead and write that negative out. It's a very similar idea to what happens if we have 2x squared. When I look at that, is this 2 included? Yes or no? Is that 2 being squared? No, because the only thing the square is on is the x. If it was written like that, the 2 would be included, right? And so then we have to square the 2. And it's that same idea. The only difference is we're looking at a negative there, okay? And so if we are looking at anything that we're being raised to a power, if we have negatives, so if I have a negative number and it gets raised to an even power, so 2, 4, 6, 8, 10, 12, 14, 16, and so on, right? Anytime it's being raised to an even power, what's going to make a negative positive? What do you have to multiply a negative by to make it positive? Another negative. Because a negative and a negative make a positive. So in even numbers, you're always going to have that pair of negative, negative, right? Because it needs a pair of 2. So you'd have 2, 4, 6, 8. All of them get that pair, which is always going to make your answer positive. So if you're ever taking a negative number, raising it to a power, it makes it positive. But when we have a negative number and we raise it to an odd power, okay, so 1, 3, 5, 7, 9, 11, and so on. So we have a negative and a negative, right? Which makes it positive. But then we have a leftover negative. We will always have that one leftover negative. And so what happens if you say negative times negative and you get positive times another negative? What does it make it? Negative. And so because in odds you always have that one remaining negative out there, it will always make it negative. So using that little rule can help you with using your calculator and making sure you're checking yourself as you go. Okay? It's a super easy thing to go, oh, okay, that I put a negative in there and I raise it to an even power. That shouldn't be negative anymore. You know, we can check it going like that way. All right, now we are going to look at number 3. So for number 3, what do I need to do with the exponents? Add, subtract, multiply? Subtract. So we'll do 2 minus 5. What is 2 minus 5? Not just 3, but negative 3. Because the big thing we have to make sure we do is we take the power of the top and then subtract the power of the bottom. Okay? And what happens when we have a negative exponent? Not a decimal. I don't want us to do these with decimals. I want us to do it with fractions. So where does it go?
On the bottom.
On the bottom. So 1 over 5 to the third. And what is 5 to the third? 1 what? Yep. That is our answer. And the reason I'm having us leave them as fractions is because when we have variables, we have to leave them as fractions. We can't make them into decimals. Yes, Casey?
I got an E. Mine said E.
It is saying that it moves that to the decimal place to the right. I don't know why it's saying that. Let me see if I can.
Probably put it inside.
All right. Now we're going to flip to the back. And before we do number 4, we're going to talk about we're going to do like a simpler version of number 4 to talk about. So, what we're going to do, okay, is we're going... We are going to say 2/7, but instead of us doing this being raised to a bigger power, we're going to start with just looking at what happens when we raise it to the -1. Okay? So if we do that, we equal, where does it need to go if we put it to the power of -1? Where does that send it? To the denominator, right? So we're going to do 1/2/7 to the power of 1. Now, does the power of 1 change anything? No, it's just 2/7. So what do you do when you're dividing by a fraction? Does anyone remember? Think keep.
Change flip.
There it is. So we're going to keep the numerator, change it from division to multiplication, and then we're going to multiply it by the reciprocal, which means we have to flip that to 7/2. And 1 times 7/2 is just 7/2. So really what's happening is anytime we have a whole fraction being raised to a negative power, what it is doing is it is causing us to use the reciprocal. And so it will flip it, and so we get 7/2 to the 1. Now, which one of those is an easier thing to do? All of this or just doing this part? Just doing the bottom one, right? But knowing where that comes from is important to make sure if we ever have to do it that way, we can remember it. Okay? I am A-okay with you doing it this way. I do not expect you to always take the long way about it. Yes. Yeah, go ahead. But I do want us to make sure we're being careful when we're going through the problems. So once we do this, okay, I'm going to come down here and I'm going to do this actual problem. So the whole thing is being raised to a negative power. So since the whole thing is being raised to a negative power, what do I need to do with it? What do I need to use? To flip it, or the reciprocal. So we're going to say 7/2 to the 3rd power. So we get 7 cubed divided by 2 cubed. What is 7 cubed? $343. Then we're going to divide that by what is 2 cubed?
8.
And that is our answer. The only time that something like that is a little bit different, okay, is if I have something like this. So if I have something like this, is the whole thing being raised to a negative power? Or is just the A? Just the A. So do I need to flip the whole fraction? No, because it's just the A that needs to be flipped. So in that scenario, what we would do is we would leave the A up, or we would leave, what's the coefficient of that A? What's in front of it? What do we know? 1. We're going to leave the 1 alone, and then we're going to move the A down. Okay? If only part of it is being raised to the negative power, you only have to move the part that is. So let's change this around just a little bit more. So if I keep that same problem, but instead of that right there in the front, I'm going to put a 3. Is the 3 being raised to the negative power? No. So since the 3 is not being raised to the negative power, where should it stay? Numerator or denominator? Numerator. Okay? What if I change the way I write that? Now is the 3 being raised to the negative power? Okay, is the 2 on the bottom being raised to the negative power? No. So I need to move the 3A. So I would do 2 times 3A. Which, what is 2 times 3?
6.
we get 6a. Okay, that is all that's the, if only part of it is being raised to a negative power, you only have to move the part that is. If the whole thing is, flip the whole thing. All right, so let's look at number 5. Okay, we have division right there. So what does that mean we need to do with our exponents? Add, subtract, multiply? Subtract. So we'll do 3 to the 4 minus negative 2. What is 4 minus negative 2?
6.
Just 6. And what is 3 to the 6th? 729. And that's our answer. Now we're going to look at number 6. Now when we multiply, what do we need to do with the exponents? Add, subtract, multiply. Add. So what we're really saying is 3 plus 0 plus negative 5. What is 3 plus 0 plus negative 5?
Negative 2.
Negative 2. So where does that send that? Because remember, it is technically the same as saying over 1. And so when it does that, it flips it.
So it's 1/12.
Not 1/12, because we have 1 over 6 squared. What is 6 squared? 6 times 6 is 36. That is the second most common mistake that'll happen this unit, is us forgetting that a power means to say multiplying by itself that many times. So like 6 squared is saying 6 times 6 twice versus saying 6 times 2. Okay, we got to make sure we don't do that, because that'll be the second most common error. The first one will be the signs, and then the second will be that. And all right, number 7. This one. When I look at this part right here, is that negative 3 squared, or is it the negative then just 3 squared? Is the negative included there? No, right? Because there's not a parentheses in between, like around the number and the 2. Okay, so we say negative 3 squared. What is negative 3 squared if in our calculators without any parentheses? Because do I or do I not include that negative? It's negative 9. That negative doesn't get included, so we just bring it over, and then 3 times 3 is 9. Then we still have times 5. Now, I want you all to find the answer to this. There's 2 ways we could find it, so y'all do that one real quick. If you've done it, either of those strategies, it works, okay? This is the way you would do it if you have variables involved. And this is the way you would do it if you didn't have variables involved. So what do you get for both of those, though? You do get negative 7, what was it? 29 times what?
I did not get that.
1 what?
25.
If you do it the first way, you'll get that first. But if you do it either way, what would be the final answer for both of them?
191,000.
And then what?
125.
And that is where we're going to wrap up for the day.